This is on the collision theory of chemical reactions. So the molecules inside a container will start colliding, and afterwards through a point automatically the molecules start moving out. We'll discuss more on the collision theory of chemical reactions now. Though Arrhenius equation is applicable under a wide range of circumstances, which was developed by Max Strauss and William Lewis in 1916 to 1918, provides a greater insight into the energetic and mechanistic aspects of reactions. Let me move on to the kinetic energy. See, I am trying to show you the particles or molecules which is rotating or which is emerging. You are able to see the particles are rotating in the free space as shown now. Let me work it out a 3D of how the particles movement differs based on the temperature. You are able to see the particles are moving inside an element like this. This is at 0 degrees Celsius. As you know, the kinetic energy is equal to half mv square. Now once the temperature increases, you are able to see the movement is increasing as a whole. For the higher temperature, you are able to see the number of molecules, the speed is increasing. When compared to the lower temperature, the number of molecules is reduced in the higher temperature, but the speed is increasing really faster. Once if it go back to the lower temperature, the number of molecules will get in. Now I'll take different ions, helium and neon. This is the movement of particles at a 0 degree Celsius for helium and neon. Now I'm going to increase as a whole. Let me check it out. I'm increasing the temperature now. You're able to see the movement of particles, it's really faster. The number of atoms for helium, it started increasing, it became reduced gradually, and the speed is increasing. Over here the same thing happening, but neon got more number of atoms when compared to helium and became 0 at a particular point. It's based on the kinetic theory of gases. According to the collision theory, the reactant molecules are assumed to be hot spheres, and reaction is postulated to occur when molecules collide with each other. You are able to see the molecules are warm here and this is cool here, and it started colliding now. You are able to see it here. So this is referred to as collision theory. The number of collisions per second per unit volume of the reaction mixture is known as collision frequency. Another factor which affects the rate of chemical reaction is activation energy, which we knew it well. For a bimolecular elementary reactions, A plus B will give the products. The rate of the reaction can be expressed as a rate equal to Z of AB e power minus EA divided by RT, where ZAB represent the collision frequency of reactants. A and B and e power minus EA by RT represent the fraction of molecules with energies equal to or greater than EA. Comparing the above expressions, Arrhenius equation, we can say that A is related to collision frequencies. The value of a rate constants are fairly accurately for the reactions that involve atomic species or simple molecules, but for complex molecules significant deviations are observed. The reason could be that all collisions do not lead to the formation of products. I want to show you a 3D of how the right direction collision can happen and indirect or incorrect direction of collision which is happening. So I'll take my ozone O3 with carbon monoxide. I'm going to heat it. Once if it is in the right direction, you are able to see carbon will pick one oxygen and it will become carbon dioxide and oxygen is spinning out. Let's see a 3D of how it reacts. Now carbon took one oxygen, became carbon dioxide and oxygen, which is our reaction I specified. Now if it is in the wrong direction, you are able to see it will collide and it won't get any oxygen. The collisions in which molecules collide with sufficient kinetic energy, that's called as threshold energy, and proper orientation so as to facilitate a breaking of bonds between reacting species and formation of new bonds to form the products, that's called as effective collisions. For example, the formation of methanol from bromomethane. It's a methane, it's not ethane. From bromomethane depends upon the orientation of our reactant molecules. Here is the bromomethane structure. The proper orientation of reactant molecules lead to the bond formation, whereas improper orientation makes them simply bounce back and no products are formed. Here this is bromomethane, it's not ethane. So here is the exact bonding. To account for effective collisions, another factor P called the probability or steric factor is introduced. It takes into account the fact that in a collision, molecules must be properly oriented. So rate is equal to P into ZAB e power minus EA divided by RT, where ZAB is the collision frequency of reactants, P is the probability factor, AB e power minus EA by RT is a fraction of molecules with energies equal to or greater than EA. You are able to see you got your bromomethane mixed with a hydroxide ion to give methanol and bromine ion. So here is the exact structure of a bromomethane with a hydroxide. With improper orientation, you are able to see there won't be any product, because this guy is moving in this direction and this guy in this direction. So there won't be any product. But over here you got an intermediate bonding of this one. You're able to see this OH is here. And it forms a methanol and bromine ion. So orientation is really an important factor. So let's discuss more on the collision theory with a 3D now. I got NO3 plus carbon monoxide, it becomes a nitrogen dioxide and carbon dioxide. Okay, now let me show you if the direction of the reactants are same or it's in the right direction, automatically there will be a collision happening and there is an absorption of an atom will happen, or else nothing will happen. Let's see how it works. You are able to see this is called unsuccessful collusion. Now I am changing the direction. Now it's able to capture it. This is called a successful collusion. So that's the difference. This is referred to as unsuccessful collusion, whereas once if we change the direction, it will become a successful collusion. This is how the elements or reactants react so that you will be getting a product. And this is kind of a displacement reaction. The reason is NO3 is displacing an oxygen to carbon monoxide to form carbon dioxide. Thus, in collision theory, activation energy and proper orientation of the molecule together determine the criteria for an effective collision, and hence the rate of chemical reactions. Collision theory also has a certain drawbacks as it considers atoms, molecules to be hard spheres and ignore their structural aspects.